In this video, we're going to discuss about limits at infinity. So let's have the definition. Let A be a subset of R, F be a function from A to R, and let A comma infinity be a subset of A for some A element of R. L is element of R, or a real number L is the limit of F as x approaches infinity or as x increases if for any positive epsilon there exists k greater than a. Take note that yung a ay ito, such that for all x, lahat ng x na greater than k, where yung k na yun ay greater than a, ito yung distance sa lahat ng x na yon, kapag kinuha mo yung f of x, yung distance ng f of x tsaka L ay less than epsilon. Okay? So kapag ganun nangyari, then yung L na yon ay limit ng f. Okay? So ibig sabihin lang nun, yung mga x na mas mataas sa k, okay, or yung mga x dito sa values na to up to infinity, kahit alin i-substitute mo, nasa loob siya ng epsilon, yung f of x. Okay, yung distance nito nasa loob ng interval ng L minus epsilon, L plus epsilon. So kung babalikan natin yung graph. So di ba kapag nasa loob ng interval na L minus epsilon, L plus epsilon, ibig sabihin nun yung L ay limit. Di ba? Kung babalikan natin yung sa definition ng limit. So ganun yung nangyari. And diyan, kaya siya naging for all x greater than k kasi nga approaches to infinity yung x natin. Yung x ay approaches to infinity. So ang napalitan dyan sa part na yan, yung kapag yung limit nag-approach sa constant, di ba may nag-exist na delta. Pero dito, yung x ay nag-i-increase without bound. Okay? Doon sa case na to, isasulat natin siya as limit of f of x as x approaches positive infinity is L. Then, for another definition, let A be a subset of Rf, a function A to R, and let, so dito naman, ang open interval natin ay negative infinity B, subset of A, for some B element of R. Yung L daw ay limit ng f as x approaches negative infinity if for any positive epsilon there exists k less than b naman. Okay, yung mga nasa left side ng b, such that lahat ng x less than k or k less than b, or as x approaches to negative infinity, kapag nilagay mo siya sa f of x, kinuha mo yung distance ng f of x tsaka L, nasa loob siya ng interval na L minus epsilon, L plus epsilon. Or yung distance niya less than sa epsilon. Take note again, kapag ang distance less than sa epsilon for all x, so that means yung L natin ay limit. Yung limit niya ng function, okay? And we will write it as limit of f of x as x approaches negative infinity is L. Example. Show that limit of 1 over x squared as x approaches infinity is 0. Okay? So, meron dalawang part ulit. First, discussion. Ang gagawin natin sa discussion, hahanapin natin kung yung value ng k. So, ano yung possible value ng k para masatisfy yung definition. Kasi nga, according sa definition, di ba, there must exist k. So, for any positive epsilon, there must exist k such that for all x greater than k, eto dapat masatisfy. Okay? So, hahanap tayo ng k. So, given positive epsilon, we want, take note that k is a natural number. Yung k na tinutukoy natin doon, natural number, such that for all x, so yan yung nasa definition natin, dapat daw yung absolute value ng 1 over x squared minus yung L natin na dito ay dapat yung 0. So, dapat ito less than epsilon para makuha natin yung limit. Okay, so dito tayo kukuha ng idea. So, ito, absolute value ng 1 over x squared minus 0. Same yan ng absolute value ng 1 over x squared less than epsilon. Tapos, pwede na nating tanggalin yung absolute value kasi naka-x squared naman yan eh. So, 1 over x squared less than epsilon. Okay? Tapos, reciprocal natin. So, mababago yung from less than magiging greater than. Okay? Tapos, square root natin magiging x greater than 1 over square root of epsilon. So, yung x greater than 1 over square root of epsilon. So, yun yung gawin natin k. Okay? So, take k to be equal to 1 over square root of epsilon. Okay, so doon na tayo sa proof. Let epsilon greater than 0, choose k, natural number k, to be equal, no. Hindi natin pala sure kung natural number yung 1 over epsilon, di ba? Yung k natin dapat natural number. So let's say yung k na yon ay greater than na lang sa 1 over square root of epsilon. But that value, siya yung unang-unang integer na mas mataas sa 1 over square root of epsilon. So let's choose k greater than 1 over square root of epsilon, where k is a natural number. Okay? Then, from definition, x greater than k implies, kapag in-square natin yan, x squared greater than k squared, and this is greater than 1 over epsilon. Pag in-square natin to, tama? Okay, kasi mawawala yung square root. So, 1 over epsilon na siya. So, that means, yung x squared natin, greater than 1 over epsilon. And then, reciprocal natin, 1 over x squared less than epsilon. Okay, kinuha natin yung reciprocal. Okay? Ba't kinuha natin yung reciprocal? Kasi, makikita natin sa definition, dito kasi, ang given natin yung 1 over x squared, dapat less than sa epsilon. So, ito, yung definition, ito, f of x, yung 1 over x squared, tapos yung L, dapat yung distance niya less than sa epsilon. Kaya kinuha natin yung reciprocal. And then, pwede natin siyang isulat as 1 over x squared minus 0. Ang L kasi natin dito ay 0. Tapos lagyan natin absolute value. Para kitang-kita natin yung definition. So, f of x minus L, absolute value of f of x minus L is less than epsilon. So, that means, yung limit ng 1 over x squared as x approaches infinity is 0. Okay, next. I-define naman natin yung limits at infinity na ang nag-a-approach sa infinity. So, infinite limits ng limits at infinity combined. Okay, so number 1, let A be a subset of R if a function from A to R and this one, subset of A for some A element of A. So, sa definition ng limits at infinity yan. So, f approaches infinity or f increases without bound as x increases without bound if it satisfies this definition. for any alpha, so gagawin ko sanang A yan kasi meron na tayong A eh. Kaya alpha na lang. So for all alpha element of R, dapat may mag-exist na natural number K. Okay, such that for all x greater than K, so sa definition ng ano yan sa definition ng limits at infinity. So similar, no? Pero itong sa alpha, sa infinite limits, kung mapapansin nyo, yung f of x, for all x greater than K, yung f of x greater than alpha din. So maaalala nyo dyan yung definition ng infinite limits. Okay? So combine siya. Now, sa ganitong case, isusulat natin siya as limit of f of x as x approaches positive infinity is positive infinity. Then for number 2, ito naman yung nag-approach or nagde-decrease without bound. So let A be a subset of R, f a function from A to R, and we have also this one. So sa ano pa rin yan, sa limit of infinity. Pero dito yung f naman, nagda-diverge na siya or nag-approach na siya sa negative infinity as x approaches infinity if for all beta, so yung dun sa definition ng infinite limits, B ang gamit natin. So dito beta na lang kasi nag-alpha tayo kanina. So for all beta element of R, may mag-exist na natural number K such that for all x greater than K, so sa in limit of infinity, sa x yan, then yung lahat ng f of x for any x less than beta. So nagde-decrease siya without bound. Okay? So we will write this as limit of f of x as x approaches infinity equals negative infinity. Okay, so define lang natin. So pwede yon na as x approaches to infinity or as x increases without bound, yung f of x natin nag-approach sa infinity o kaya sa negative infinity. Similar yan. So hindi ko na pinakita yung definition. Similar yan kapag yung f of x natin nag-approach sa negative infinity. Yung x approaches negative infinity, f of x approaches positive or negative infinity. Almost similar lang naman yung definition nila. So medyo papalitan lang natin. Halimbawa ito. Okay? And yung some definition. Okay? Okay. So let's have this theorem. Let A be a subset of R, F be a function from A to R, and let A, infinity be a subset of A for some A element of R. Assume that g of x is positive for all x or for any x element of A. And let's say for some L, for some real number L, such that L must not be equal to 0, we have the limit of f of x over g of x as x approaches infinity equals L. Okay, so this is just an assumption. Okay, so let's have letter A. Kapag daw yung L na to ay greater than 0, then yung limit daw ng f of x as x approaches infinity is infinity. If and only if limit of g of x as x approaches infinity equals infinity. So alam natin yung meaning ng if and only if. Ibig sabihin, ito implies dito. Ito implies ito. Okay? So ito yung general assumption. Next, for letter B naman, kapag naman negative yung L, then yung limit ng f of x as x approaches infinity is negative infinity if and only if limit of g of x as x approaches infinity is infinity. Okay? So now, bakit laging infinity? Kasi nga yung g of x natin greater than 0. Okay. Now, i-prove natin yung letter A lang. Okay? So, yung letter B halos similar lang naman ng proof yan ng letter A. So, ipapakita ko lang yung proof ng letter A. So, proof for letter A. Okay? So, i-let natin L greater than 0. Ayun yung unang hypothesis. Then since according dito, yung limit daw ng f of x, limit ng f of x over g of x as x approaches infinity is L. Then, kahit anong epsilon yung piliin natin. So, magbigay tayo specific. Then, for, let's say, epsilon equals 1/2 L, since epsilon is arbitrary. Then, from the definition, may mag-e-exist na natural number K. So, there exists natural number K, definition ng limit at infinity, such that if x is greater than k, then the distance between f of x over g of x and L is less than epsilon, or that epsilon is 1/2 over L. If and only if, okay, so pwede nating gamitan to ng so ito na yung sa definition ng limit at infinity. So ito i-manipulate lang natin to. Okay? Ang gawin natin yung property ng absolute value. So alisin natin yung absolute value. Magiging yan? Negative 1/2 less than f of x over g of x minus L less than 1/2 L pala, may L. Okay? So property ng absolute value. Tapos mag-plus tayo both sides ng L. So this is, eto pa nag-plus tayo ng L. L plus negative 1/2 positive 1/2, no? So 1/2 L. Tapos eto mawawala yung negative L, magiging f of x over g of x na lang. Tapos ito 1/2 L plus L, magiging 3 over 2 L. Tapos, multiply natin both sides by g of x. Hindi mababago yung inequality natin. Pwede natin i-multiply yung g of x. Bakit? Kasi yung g of x natin positive. Ayan o. G of x is greater than 0. So, multiply natin. So, this is 1/2 L g of x less than f of x less than 3 over 2 L g of x. Now, okay, so gagamitin natin yan. Doon tayo sa hypothesis, limit of f of x as x approaches infinity is infinity implies, okay, so kung yung f of x mas mababa sa 3 over 2 L g of x, then yung theorem natin dun sa infinite limits sa nakaraang lesson, kapag yung mas mababa for all x nag-a-approach sa infinity, then etong mas mataas mag-a-approach din yan sa infinity. Okay, so this implies that yung limit ng 3 over 2 L g of x as x approaches infinity also infinity. At kapag yung limit ng 3 over 2 L, a multiple of L, a multiple of g of x, nag-a-approach sa infinity, sigurado tayo na yung limit ng g of x as x approaches infinity is also infinity. Okay, kasi multiple of g of x yan. So, done na tayo sa isang side. Pero, kung mapapansin nyo, if and only if yan, so mula dito, na-prove lang natin na ito implies ito. So, prove naman natin ito implies ito. Okay? So, pero, same lang sa gagamitin natin dito sa dito sa ginawa natin nung una. Yung limit ng g of x as x approaches infinity is infinity implies yung ano niya, yung multiple niya, okay? So limit ng 1/2 L times g of x as x approaches infinity is also infinity. So pwede pa rin yan kasi multiple niya yan, 1/2 L. Nag-multiply lang tayo ng 1/2 L. Pero yung x natin approaches infinity. Okay, so kahit sa g of x approaches infinity yung x, so halos madadaanan pa rin yan eh. Okay? Now, kung yung limit ng 1/2 L g of x ay approaches sa infinity, which is yung 1/2 L g of x mas mababa sa f of x. So, gamit yung theorem ulit nung sa nakaraang video natin sa infinite limits, kapag yung mas mababa nag-approach sa infinity, yung mas mataas mag-approach din for all values of x. So, that means yung limit ng f of x as x approaches infinity is also infinity. So, na-prove natin yung pabalik na. So, therefore, for L greater than 0, so dito L greater than 0, no? Kaya sure tayo na ito hindi magna-negative, pati yung sa kanina. So, therefore, yung limit ng f of x as x approaches infinity is infinity if and only if limit g of x as x approaches infinity is also infinity. Okay, so ito yung proof for letter A only. So sa letter B ng definition, ito yon. Sa letter B ng definition, so kayo na bahala mag-try mag-prove niyan.